Next up, we're going to factor and solve things that do not have a 1 in front of the a squared. They're going to have some other type of number. So by the end of this lesson, you should be able to factor things with a leading coefficient that's not 1, and then also solve them. So let's say I asked you to multiply these two things together. We could double distribute, and we would get 6x squared here. 2x times 4 gives us 8x. 1 times 3x gives us 3x, and then 1 times 4 gives us 4. Now if we combine the things that are alike, we end up with 6x squared plus 11x plus 4. So when I ask you to factor one like this 6 out front, there's two different ways that we could get 6. We could have a 2 and a 3 in the beginning, like this happens to be, or we could have a 1 and a 6. And both of those would end up giving us 6x squared. And then depending on what we have here, that determines what we have to have at the beginning or at the end. So the thing that makes these a little different is that number out front, but there's still only one possibility that works. So we're going to do exactly the same thing as we did before, except we're going to add one little step. So remember how we said we need two numbers that multiply to make the number on the end and add to make the number in the middle? One of those is the same. We still want to add to make 11, but this time we want to multiply to make 6 times 4. So our first and our last multiplied together, and that number is 24. Now the two numbers that do this, in this case, are 8 and 3. And now it's not as easy as before where we just put in 8 and 3, but instead what we're going to do is we're going to use 8 and 3 here to break up this 11. So it turns into this. And it doesn't matter what order you put this in. But now that this has 4 terms, we're going to factor by grouping. So remember that means that you're going to take the first two terms and find what they have in common, so a 2x in this case, and then I would have 3x plus 4, and then take these two terms, and since there's nothing in common, remember that means there's a 1 in common, and you'd have 3x plus 4. And now remember, just like any other factoring by grouping we've done, you know you're doing something right if your two things in parentheses are the same. So when you factor that out, you have 2x plus 1. And that's what we started with over here. So, two different things going on here. You have to multiply to make the first and the last thing together, and then you have to factor by grouping. So let's try another one. Remember, just like any other problem we've done, you should always look for a GCF first. If there's no GCF, then solve one of the ways that we know how to solve. So 2y squared plus 5y plus 2. There is no common factor. So I notice this has a 2 out front. So then I need to find two numbers that add to make the number in the middle and multiply to make these two guys multiply together. So 4. So our numbers that make 4 are 4 and 1. And 2 and 2. So 4 and 1 are going to be what we use. And remember, 4 and 1 aren't going to be our answers, but instead it's going to be what we use to separate this 5y into having 4 terms. Because once we have 4 terms, remember we can factor by grouping. So then we will take out a 2y here. I'll be left with y plus 2. Just like the last problem, these guys have nothing in common, so I have to take out a 1. And you know you're doing something right if you end up with the same thing in your parentheses. And then outside of my parentheses is 2y plus 1. So this is the factored form of this. And remember, just like all the other ones, you can double distribute to check your answer. Let's try this next one. So look for a greatest common factor. 23 is a prime number, so we know right away we have no GCF. So I notice there's a 6 here. So I got to find two numbers that add to make negative 23. And they got to multiply to make these two guys multiplied together, which is 42. Now to multiply to get 42, we have 6 and 7. Those won't add to make 23. But because we're adding to make a negative number and we're multiplying to make a positive, I know both of them are going to be negative, which helps me. So then start running through the other ones. You have 1 and 42, you have 2 and 21, and that's what we're going to end up using. And remember, these are used to split up this thing into 4 terms. And just like all the other ones, it doesn't matter what order you put the 2 and the 21 in. But once you have 4 terms, then you can factor by grouping. So these guys have a 2 and an n in common, and I'm left with 3n minus 1 to get that negative 2n. And then this next one, remember, if ever the front term is negative, you got to take out a negative. And 21n and 7 have a 7 in common. So this gives me 3n. And then this is kind of tricky, but to end up with negative 7, or positive 7, sorry, I would have to multiply by negative 1. And then we know we're doing something right because our two parentheses are the same. So I get 3n minus 1, and then what's left over is the 2n minus 7. I always do a quick double check that my first 2 terms multiplied together give me this, and my last 2 terms multiplied together to give me that. You can go through and double distribute the whole thing and make sure it works, but that's just a nice quick check to make sure you know what's going on. I want you guys to try C on your own. A polynomial that cannot be written as a product of 2 polynomials with coefficients is called a prime polynomial. So just like we talked about prime numbers a second ago, they're numbers that don't have factors. A polynomial can be prime also. So this example tells us to factor 4x squared minus 3x plus 5 if possible. If it cannot be factored, write prime. So what we're going to do is start it just like any of our other problems. Look for a GCF first, and in this case there isn't one. We have 2 prime numbers here, 3 and 5. And then we'll figure out what 2 numbers add to make the number in the middle and multiply to make the numbers on the end. So remember, just like before, we're multiplying these 2 guys together. Now the thing that makes this prime is that there are no numbers that do this. So if I wanted to factor 20, I have 1 and 20. There's no way those are going to add to negative 3. I have 2 and 10, again, same thing, and I have 4 and 5. Those are my only options, and there's no way that these guys add or subtract to make negative 3. So once you've proven that, then you can write prime. This cannot be factored. So I know these are in the prove it section, but I'm going to do one with you because you already did one of the other ones. Now the only difference between these ones and the other ones is that these guys equal 0, which means we now have to solve. But this is old news because we can use the 0 product property. And then the awesome thing about solving is you can always plug it in and check it. So, just like all the other ones, the first thing you do is look for a greatest common factor. We do not have one. So then we jump to finding 2 numbers that add to make the number in the middle, which is negative 1. And remember, it has to multiply to make these 2 guys multiplied together, which is negative 6. So numbers that multiply to make 6 are 6 and 1. Those won't add to 1. And 3 and 2. Those are going to be what we're going to use. And because we want them to multiply to make negative, one of them has to be negative, and 3 has to be negative to add to make negative 1. So remember, these guys aren't our answers, they're just what we're going to use to separate this. So you have 2t squared minus 3t plus 2t minus 3, and it equals 0. And now once we have these 4 terms, we can group things up. So these guys just have a t in common, and I would be left with 2t minus 3. And these guys have nothing in common, which remember means a 1, and I would have 2t minus 3, and it still equals 0. So you know you're doing something right. We ended up with 2t minus 3 in both my parentheses, so my other parentheses have to be t plus 1. And then we were done with the other problems, but because this equals 0, we need to use the zero product property, which says that this stuff here could equal 0, or this stuff here could equal 0. And now these are both linear equations that everybody can solve. So I'll add 3 to both sides for this one, and then divide by 2. Oops. So this ends up being 3/2, or 1.5. And then this one's a little easier. I just have to subtract 1 from both sides, so I get -1. Now both of these I can plug in and check. So you guys just have this one to try on your own. Make sure you write down any questions you have, and we can go over them together in class. Enjoy your night.